Anthropic said Tuesday night that the Commerce Department had lifted export controls on Claude Fable 5 and Mythos 5. So the first fact today is simple. The blocked models are coming back. TechMeme has the morning stack of coverage around the rollout, and the Hacker News thread on Anthropic's post is already enormous, which tells you how much of the developer world had been waiting for a yes or no on this. But the restoration isn't a return to the old product. The models are coming back with credits and fallback routing. They also carry government conversations, cybersecurity review, and a messy side story about Claude code tracking that Anthropic reportedly had to walk back after backlash.
The credits make it feel less like ordinary release management and more like a service outage with geopolitics attached. If you were blocked from Fable or Mythos, Anthropic can say access is being restored, but the last few days taught everyone that a model can be available in the product page sense and still unavailable in the policy sense.
Right. We have to be disciplined about what changed. Last week, the story was restriction. Today, the update is restoration. Anthropic gets Fable 5 and Mythos 5 back into circulation after the Commerce Department lifts the controls. Some reports also say Fable 5 will route some coding and debugging requests to Opus 4.8, while Anthropic works down false positives. That can sound like release plumbing if you only hear the model names. It feels different when your workflow depends on a specific model answer, and the system hands part of the job to another model because the access layer is still being tuned.
That is a weird kind of product boundary. The user asks for Fable, the policy environment says yes again. The service says yes with conditions, and then the runtime may still decide that one slice of the task goes to Opus. The model selector becomes a compliance object. It isn't only latency and cost anymore. The runtime has to decide whether this account can touch this model for this task under the rule set in force right now.
And the trust problem isn't only that the government can intervene. It is that every intervention teaches users to look for hidden product surfaces. One of the supporting TechMeme items today points to backlash over a covert Claude code tracking feature, with Anthropic rolling back or revising it after users found it. I don't want to overstate that report, because the reporting gives us the backlash and rollback detail, not a full technical audit, but it sits next to the export control story in a way that matters. If access to the model now depends on review and identity and task classification, users are going to ask what telemetry is being gathered to make those calls.
And developers are unusually sensitive to that because code assistants run close to private context. They see repo names, prompts, file paths, secrets if the boundary fails, and half-finished business logic. A tracking feature in a consumer chatbot is already a trust issue. A tracking feature in a coding agent feels like someone asking to inventory the workshop while you are still building in it.
The other distinction I would keep from today is policy relief versus dependency relief. The policy changed back, but the dependency stayed. If you are using these models through Claude Code or an API, the lesson isn't that Anthropic is unreliable. That is too simple and probably unfair. Frontier access now depends on actors outside the vendor and outside the customer. Commerce, national security review, product telemetry, account identity, and model fallback logic are all in the path.
That makes the restored access useful and uneasy. Fable and Mythos are back, but the product that came back has more visible machinery around it. You can imagine why Anthropic would want that machinery. You can also imagine why a developer would say, fine, then show me exactly when the machinery touches my work.
There is a generous read here, too. If a frontier lab is trying to satisfy U.S. export controls, reduce false positives, keep high-end coding access working, and reassure enterprise buyers, the pristine version of the product isn't enough. You need eligibility checks, fallback behavior, and logs that can prove what happened. That same apparatus lets the company keep the product available while giving users new reasons to worry about observation and sudden substitution.
And that is why this is a fresh update rather than a replay of the restriction story from last week. The restriction was temporary. The access layer stayed visible. Once users have seen the gate, they don't unsee it.
That is the lead for today. Fable and Mythos are coming back, but the important artifact is the product boundary around them. Who gets access? What gets routed elsewhere? What gets logged? and who has authority to change the answer after the vendor has already shipped. Axios reported this morning that a UN-backed AI for Good commission is being announced with tech executives and world leaders around the table. The Axios item names Amazon's Andy Jassy and NVIDIA's Jensen Huang. On the same morning, The Guardian has a UN inequality report, warning that uneven AI adoption could widen the gap between richer and poorer countries.
Those two items belong near each other, but not because they prove one grand theory. They put two rooms next to each other. In one room, CEOs and states talk about rules. In the other room, the UN is saying that countries outside the data pipelines and standards process can lose control over the terms of adoption.
Exactly. And the risk with any UN story is that it turns into mist. Global governance, coordination, principles, and all the words that make people stop listening. The concrete version is simpler. The companies that build the models, chips, and cloud platforms have operational knowledge that governments need. Governments have law, procurement, export control, and public legitimacy. The countries with less capacity are worried that the rules will be written around systems they didn't build and can't inspect.
I wouldn't wave away the standards question. A country can adopt AI tools and still not control the categories the tools use, the data contracts they require, the safety thresholds they inherit, or the audit trails regulators will later ask for. That is a different kind of dependency than buying compute. It is dependency on the grammar of the system.
And you can hear the connection to Anthropic without forcing it. One frontier lab gets relief from export controls. On the same day, the UN is trying to host a table where companies and states negotiate control across products, law, standards, and cross-border agreements. Commissions exist constantly. This one matters because the product layer is where policy is enforced, and the policy layer is trying to understand the product.
That is also why CEOs at that table make sense, even if it makes people uncomfortable. A normal software product can often be regulated after the fact. With frontier AI, the model behavior, chip allocation, cloud account, data pipeline, safety classifier, and licensing terms are tied together. A regulator can write a sentence, but someone has to translate that sentence into system behavior.
The inequality report keeps that from becoming a club of incumbent states and vendors congratulating themselves. If the standards are written by the countries with compute and the companies with distribution, then everyone else gets a take-it-or-leave-it version of AI governance. That doesn't require malice. It can happen through meetings, procurement language, default contracts, benchmark choices, and data schemas.
And through absence. If you aren't in the room when the acceptable use categories are defined, later you get told that your local use case is edge case noise. That is how a technical standard becomes a political fact without anybody standing at a podium and saying, "We are taking control."
This commission still has to prove it is a negotiation surface and not a photograph. Today, the factual development is that the UN is trying to put states and tech executives in one governance process, while its own reporting warns that the benefits and control of AI aren't spreading evenly. That is enough. We don't need to inflate it into a constitutional moment to see why it belongs in the day. Etched said Tuesday that its first AI inference racks have shipped. The company points to A0 tapeout, more than $1 billion in customer contracts, and $800 million raised. Tech memes supporting coverage has the same basic contours. This is a young AI chip company trying to move from the pitch about transformer-specific hardware into customer tests and shipped racks.
The phrase "first racks" changes the status of the story because it moves Etched out of slide decks. A chip company can raise a huge round on the promise that its architecture is better for inference. A rack is where the promise starts paying rent. It has thermals, failure rates, cabling, firmware, software integration, and customers who eventually stop clapping and start measuring.
And the measurement questions aren't ornamental. For Etched, the claim has always been that specializing for transformer inference can beat more general accelerators on the workloads that matter. If the first customer racks are in the world, the next evidence is throughput, latency, tokens per watt, utilization under real traffic, and how painful the software path is. The money is eye-catching, but the first serious proof will be operational.
There is a fun technical tension there. Specialization buys you speed by giving up flexibility. That trade can be brilliant if the workload stays where you designed it to be. It gets harder if architectures keep changing, if customers need odd model mixes, or if the serving stack has to handle a messier distribution of requests than the benchmark expected.
This also sits near the custom-silicon stories we covered last week, but it isn't the same chapter. OpenAI and Broadcom, Qualcomm, and the big national capacity plans are about who owns more of the stack. Etched is a narrower question. Can a specialist inference architecture turn model-serving demand into a wedge against NVIDIA and the cloud incumbents? The $1 billion in contracts says customers are at least willing to test that bet.
Contracts prove appetite and maybe procurement seriousness. They don't prove the rack in customer deployments. The rack has to prove the weird parts. Does the compiler make customers angry? Does the power profile hold up when traffic is bursty? Does one model family look fantastic and another one look awkward? Does the support team become the product for the first year?
And still, I wouldn't minimize it. Hardware stories spend years in the fog before there is anything a customer can touch. Etched is saying customers can now touch the system. If those racks show strong numbers outside Etched's own demos, inference becomes a more contested market, and the specialized chip argument gets a living example rather than a diagram.
That is the altitude for this one. Big numbers, a physical milestone, and unfinished proof. I don't need it to be the chip war of the decade to care about it. I want the customer traces.
There is a broader capacity cluster today, and I want to keep it grounded because we covered national AI capacity on Monday. The fresh examples are Korea's science ministry announcing a physical AI strategy, Japan backing a domestic foundation model consortium involving companies like SoftBank, Honda, and Sony, ByteDance planning a 1 gigawatt data center complex in Brazil, MGX closing a $49 billion AI fund, and Chinese automakers pushing local AI chips.
That is a lot of different machinery under one label. Korea is talking about robots and physical systems. Japan is talking about domestic models and industrial partners. ByteDance is talking about energy and geographic placement. MGX is capital. Chinese automakers are supply chain self-reliance. These actors didn't copy the same plan. AI capacity now has to be purchased in several currencies at once: money, power, chips, national legitimacy, and local firms that can absorb the work.
Yes, and the phrase physical AI in Korea's ministry release is useful because it pushes the discussion out of chat windows. If AI systems are going into factories, robots, vehicles, logistics, hospitals, and defense-adjacent industries, then capacity also means sensors, actuators, memory, batteries, factories, testing grounds, and liability. It isn't just a data center with a model on top.
Japan's consortium angle has a different flavor. A domestic foundation model backed by industrial firms is partly about language and local market fit, but it is also about not being a tenant in someone else's stack forever. A car company and an electronics company don't look at models the same way a chatbot startup does. They see interfaces into manufacturing, mobility, entertainment, service, and product support.
The ByteDance Brazil item is the one that makes the physical side hardest to ignore. A 1 gigawatt data center complex isn't a product launch. It is a power and land event. It touches grid planning, water, local politics, and tax policy. It also raises a plain question. Why does a Chinese internet company want that much AI infrastructure in Brazil? The answer may be latency, market access, energy, geopolitics, or some mix of all of that. But the site itself is the fact.
And MGX closing a $49 billion AI fund is the financial mirror of the same problem. If you want influence over the AI stack, you can build models, own chips, host data centers, buy equity, or become the capital partner every lab wants near the table. Money isn't a substitute for compute, but enough patient capital can decide who gets to keep buying compute while everyone else waits.
Then the Chinese automaker chip story gives you the manufacturing version. If vehicles are becoming AI platforms, car companies don't want every inference path, cockpit feature, driving system, and factory model dependent on imported chips whose availability can change with export rules. The local chip push is partly technical and partly institutional. Can the domestic supply chain support the products domestic firms want to build?
I would be wary of flattening all of this into geopolitics. Firms are trying to avoid waiting in line. Industrial pride is in there, regulation is in there, energy arbitrage is in there. But all of those motives produce the same visible behavior. Countries and firms are buying the floor under AI, not only renting the model on top of it.
That is the fresh contribution today. Monday's episode spent time on the cabinet-level capacity question. Today's examples show how many forms the answer can take by Wednesday. A Korean physical systems strategy, a Japanese domestic model consortium, a Brazil power site, a UAE-linked fund, and local chips for Chinese vehicles. None of those is the whole story. Together they tell you that capacity is no longer a back-office procurement line. The ARXIV batch today is heavy, so I am going to keep it to one research chapter. 4 papers are circling the same idea from different sides. Large language model agents are being evaluated as computer systems, not only as chat models that produce safer or less safe text. SafeClaw Arena looks at persistent agent environments. Cache Attack looks at semantic caching. Agent Bound proposes runtime governance with receipts. Claw Arena Demijways measures whether one model can manage subagents.
That is the research turn I care about. We have had months of agent safety as behavior. Did the model refuse? Did it comply? Did it follow the prompt? These papers are asking about the surfaces around the model. Files, plugins, memory, cache keys, permissions, delegations, and receipts. That is much closer to how agents break in practice.
SafeClaw Arena is the most direct version. The paper treats claw-like agents as always-on processes inside the user's environment, with persistent access to credentials, files, tools, and external services. It builds 406 adversarial tasks across 4 attack surfaces: skill supply chain integrity, persistent state exploitation, cross-boundary data flow, and indirect prompt injection. The authors say they tested 3 platforms and 5 frontier models, with the highest overall attack success rate reaching 70%. They also report that malicious plugins succeed 100% of the time, regardless of the underlying model, because the plugins are unhardened.
The plugin result is brutal because it demotes the model from main character to accomplice. If the extension can run with runtime privileges and the platform has not hardened that path, a safer model doesn't save you. The agent is a little operating environment, and operating environments have old problems like package trust, data flow, and privileged code.
The paper even gives a useful hardening comparison. CClaw, their streamlined variant with added defenses, cuts GPT 5.4's attack success rate from 70% to 22%. Partly by removing attack surface features such as a skill-bundled plugin loader. But Claude Opus 4.6 already sits near a 22% security floor across every platform and gains almost nothing from that hardening. That is a very specific result, and it cautions against one-size-fits-all conclusions about platform fixes.
It also says something uncomfortable about product ambition. Extensibility is the feature everyone wants because agents become more useful when users can add skills, packages, and services. Extensibility is also where the old software security bills come due. A safer prompt doesn't validate a package. A refusal policy doesn't isolate a plugin.
Cache Attack is smaller in surface area and just as revealing. The paper starts from semantic caching, where applications use embedding vectors as cache keys so similar queries can reuse a prior answer or intermediate result. The authors model those keys as fuzzy hashes. Their claim is that locality, which helps the cache hit more often, conflicts with collision resistance. In their evaluation, Cache Attack reaches an 86% hit rate in response hijacking and can induce malicious behavior in agent workflows, including a financial agent case study.
That one feels like a classic performance feature becoming a security surface. A semantic cache is there to make systems cheaper and faster. Then the attacker says, "Great, I will craft something that looks close enough to hit the victim's cached path while meaning something different." The cached answer becomes a tool the attacker can steer.
And notice the difference from prompt injection. The attacker isn't only trying to persuade the model inside a single conversation. They are trying to exploit infrastructure that sits between conversations, users, and agent steps. The cache is shared state, and shared state has integrity problems.
Which is why agent-bound belongs in the same chapter. It is a proposal for runtime governance that composes three authorities: delegated authorization, owner-signed behavioral constitutions, and site action contracts. The paper's phrase is that receipts bind each action to the policy artifacts that governed it, so the decision can be independently replayed. I like the receipt idea because it gives the operator something to argue about after the fact besides vibes and logs.
The useful sentence from agent bound is almost procedural. Scope permitted it, Constitution stopped it, and the receipt proves it. I wouldn't ship a system on a slogan, but the mechanism is concrete. The agent asks to act. Authorization says whether the identity has access. The owner policy says what behavior is allowed. The site contract says what the destination permits. Then the system produces evidence tied to those artifacts.
That gives you a way to talk about responsibility without pretending the model has moral agency. The agent did an action. Which delegation allowed it? Which policy constrained it? Which site rule accepted or rejected it? Which receipt can a third party verify later? That is the kind of language institutions understand.
Claw Arena-Team adds a different pressure. Can one model manage other agents? The benchmark has 41 multi-turn, multimodal, multi-directory scenarios with 258 evaluation rounds and 72 staged updates. It uses execution-based scoring with no LLM judge. The main agent can only directly perceive part of the workspace and has to command a fixed local pool of subagents, so the score measures management rather than raw task solving.
The permission result jumped out at me. The paper says no model exceeds 50% workspace-permission precision. That is a wonderfully specific failure. It means the leader model isn't only answering wrong, it is granting the wrong access while trying to coordinate work. In a multi-agent system, management quality is partly a security property.
They also report that API cost spans more than 100-fold, while the overall score spans under 4-fold, and that leaderboard scores cluster, while orchestration behaviors diverge by more than an order of magnitude. That is a warning against treating the model leaderboard as a proxy for agent management. Two models can look close on the final score and behave very differently in routing, delegation, and permission control.
So the research chapter today isn't "agents are dangerous, cue the fog machine." It is more concrete. Persistent agents have plug-in and state problems. Semantic caches can be hijacked. Runtime governance needs verifiable evidence. Sub-agent managers need permission judgment, not only intelligence. Those are computer system claims, and that makes the work feel more serious.
And it links back to yesterday without repeating it. Yesterday was about action safety and long-running agents buying things they shouldn't buy. Today's papers ask how the runtime, cache, plugin loader, delegation system, and sub-agent manager become part of the safety story. That is the progression, from the scary behavior to the machinery that made the behavior possible. One last market access item. TechMeme has a report that Apple CEO Tim Cook and EU tech chief Henna Virkkunen held constructive talks about how Apple can launch Siri AI in the European Union while avoiding fines. That isn't the day's deepest story, but it is a useful consumer platform coda to the Anthropic lead.
Because the user-facing version of access control looks completely different. With Anthropic, a developer or enterprise account is trying to touch Fable or Mythos. With Apple, millions of people in Europe are waiting to see whether they get the new Siri experience and under what platform law terms. Same general pressure, different surface.
And Apple is unusually exposed to that surface because Siri AI isn't just an app download. It sits inside the operating system. Account identity, default apps, device permissions, and the broader platform rules Europe has been enforcing. If the EU wants interoperability, competition, privacy, or steering behavior to work a certain way, Apple can't treat the AI assistant as a detached feature.
There is also a user and expectation trap. People hear AI Siri and expect a better assistant. Regulators hear the same phrase and see default placement, data access, app routing, and the risk that Apple can privilege its own services through a conversational layer. Both readings are reasonable. That is why the talks matter before the feature reaches people.
So that is the arc of the day, but not in a forced way. Anthropic gets access restored after export controls. The UN tries to put companies and states at one table while warning about unequal adoption. Etched says inference racks are shipping. Countries and capital pools keep buying local AI capacity. Agent-security researchers are testing the runtime, cache, and delegation layer. Apple and the EU are negotiating consumer AI deployment before the feature arrives closed.
Those stories clarify that access isn't a binary switch anymore. It is a set of negotiated paths: model access, hardware supply, capital, governance, runtime permissions, and consumer platform law. Each path has different actors who can say yes, no, later, or only under these conditions.
And the next concrete evidence will look different for each one. For Anthropic, it is whether restored users get predictable Fable and Mythos behavior without new telemetry surprises. For Etched, it is customer measurements from real racks. For the UN, it is whether the Commission produces rules that smaller countries can use rather than admire from outside. For agent systems, it is whether the receipt, cache, plugin, and permission work shows up in tools people run. For Wednesday, July 1st, those are the next receipts to ask for. Lenar Kess.